Welcome to another video. Today we're going to be talking about the associates and invertibility theorem. So let R be some integral domain and A be some elements from the underlying set of the integral domain R. Then A is associated with B if and only if there exists an invertible element Q from the underlying set of the ring, of the integral domain, such that A is equal to B times Q. Alright, so we're proving an equivalence. So we shall demonstrate both implications. So first, right to left. Assume that A is equal to BQ. Thus, B divides A. Since B is equal to A times Q inverse, because Q is invertible, we have A divides B, and thus A is associated with B. That was easy. Now the right to left implication. If A will equal to 0, then B would also have to be 0, because only 0 is associated with 0. Alright. Suppose A is not 0, or the additive inverse if you prefer, because B divides A, we can write A is equal to B times U, and since A divides B, we can write B is equal to A times B. Right, because that's the definition of two elements being associated, right? One must divide the other, and at the same time the other one must divide the first. Thus, A is equal to BU from up here, and this must be equal to AVU from here. We multiplied both sides by U to get BU. Alright, but then by the cancellation theorem / property, we have that from here and here that 1 is equal to UV. Okay, but then UV are associated with 1. And thus, we have shown that, from up here we knew that such a Q existed, but now we have shown that this Q is invertible, because an element is associated with 1 if and only if it is invertible, right? So we have just demonstrated that it is an invertible element, and this concludes this rather short proof.